Well, how's it going so far? Are you having a good time? Yeah. Okay.
This morning's lecture was so good.
It was. I know that this morning's lecture was really good, and I know that it's really hard to sit in a lecture at 6 o'clock. It's really hard for me to sit in a lecture at 6 o'clock, so I have sympathy for you. All we're going to talk about today are two questions, and the second one, we're just going to barely scratch the surface to give you a little taste, get you thinking about maybe some new applications of isotopes you wouldn't think about otherwise. So we're really just going to ask this question, well, which is basically, why am I giving this lecture? Why would we pull out urban ecosystems as a special case to discuss in IsoCamp? We're not pulling out grasslands or forests. We are just, for some reason, gathered here today at 6:06 p.m. to say, oh, urban ecosystems are different and there's something special about them. So I'm just going to take us all the way back to the definition of ecology and ecosystems. How many people here would consider themselves ecologists, would say your discipline is ecology? Hands up higher. So, okay, so it's less than half the group. Well, so you may or may not know that the word ecology comes from the Greek root oikos, which means house. So ecology is the study of our house, which is kind of charming, actually, in a way. And as you may have learned at one time, the technical definition of ecology is the study of the relationships among organisms and between organisms and their environment. And so the question that I have for you this evening is, are humans these organisms or not? You would say yes. Well, I know that people immediately want to say yes, because it does sort of make intuitive sense when you first ask this question. But let's turn to the ecologists in the room. When I talk about ecological processes, am I talking about human processes? Am I talking about human cultural institutions? Am I talking about political systems? What do we mean when we say ecological processes or ecosystem function, or in fact the word ecology? Just ecologists now, this is like a singing competition. What does the word ecology mean for you? Complex systems. And actually below here we have the definition of the word ecosystem, which is a complex of living organisms and their physical environment. And people always want to say, well, obviously humans are part of urban ecosystems. And while that's true, things may be changing. But when I studied ecology, I wasn't given very many tools to actually understand how humans contribute to urban ecosystems from a mechanistic perspective. Because humans just do different stuff. I mean, we've got all of that culture, all of the sociology, all of the political ecology. That's how cities work. If you want to understand how cities work, you can't ignore that stuff. And then the question arises, but what do isotopes have to do with that? So here's one of many conceptual frameworks that are available to you when you're interested in studying urban ecosystems. And what we're basically saying, in the very brief time that I have to talk about this, is the traditional view of ecology from, let's say, the 1930s onward, looked something like this. Do we have anyone here who studied the origins of urban ecology? In previous versions of this lecture, I went into this a little bit more, but I decided to devote more time to isotopes because it's IsoCamp. But in the 1920s, there was a field called urban ecology. Has anyone studied that? The Chicago School of Urban Ecology? In the 1920s, there was a discipline called urban ecology, but it was entirely comprised of sociologists. And it was after the 1920s, for reasons we don't have time to discuss, the fields branched. So until, let's say, the 1980s or 90s, ecology was conceived as a system of various drivers that had to do with the biology of non-humans, geology and physics, and patterns and processes of ecosystems that have components like primary production. And those things influence ecosystem dynamics. And human activities were seen as exogenous. So let's say you're studying the effect of climate change on ecology. Lots of people do that. Climate change is usually a box outside the ecosystem. CO2 just appears in the atmosphere. We don't concern ourselves with how it got there. But the difference in urban ecology, if you were to expand this conceptual framework now to include humans as truly those organisms that are part of the ecosystem, you gotta know how the CO2 got there in a nutshell. So now we want to know about things like demography. Who are these people who live in these urban areas? How do we think of them in different socio-demographic groups? Economic systems, because money kind of drives a lot of stuff. And there will be dollar signs on one of the graphs that I will show you today that has to do with isotopes, because money turns out to be super important. Power hierarchies, a lot of sociology today is about power and who has power. Land use and management, the designed environment, and I'm going to talk about design a lot because I think design is super important and super interesting, and so forth. So that's what makes urban ecology different, is that we're going to merge, or we're going to try and merge fields, and some of these fields use isotopes, right? I mean, do we have anthropologists here? Anthropologists use isotopes to study humans and their behavior and their activities, and we've got these other kinds of scientists that have used isotopes to study plants and animals and soils. And in urban ecosystems, you just can't really figure out what's going on unless you consider this really, really broad range of things. Does that make sense? Any questions or comments about that? Yes, so I can see now, because it's 6:15, you will be lulled into sleep unless we think. We're going to now think a little bit.